square minus 4d plus 3 into y equal to e power of x cos 2x. Okay, so this is the differential equation with the constant coefficient. The right hand side e power of x into cos 2x. So this is the type 5, e power ax into v, that is a model. Okay, now the solution of this differential equation is y, which is sum of the complementary function and particular integral. So first I am going to find out the complementary function. So first I am going to write the auxiliary equation from the given equation. So for the given equation, the auxiliary equation is replacing d by m. So m square minus 4m plus 3 equal to 0. So factorize this, 3 can be written as minus 1 into minus 3 plus 3, adding this minus 4. So that this quadratic equation is m minus 1 into m minus 3 equal to 0. Therefore m is equal to 1 and m equal to 3. There are two values for m. So the complementary function is, the two values are unequal, different values. So that the complementary function formula is a into e power m1x plus b into e power m2x. So you can treat anyone as m1 and m2. So the complementary function is a into e power m1 is 1 into xx plus b into e power m2 is 3, so 3x. So this is the complementary function. Next I am going to find out the particular integral. Particular integral pi is equal to 1 by the term d square minus 4d plus 3, d square minus 4d plus 3 into the right hand side f of x term, e power of x into cos 2x. So this is e power of x into cos 2x. Okay, now so in this type we have to replace d by d plus the coefficient of x. Coefficient of x is 1. So d is replaced by d plus 1. Already I told you this is type 5. In this type 5, e power ax into v. So first you have to operate e on d by replacing d by d plus a. So here a is 1. So d is replaced by d plus 1. After replacing d by d plus 1, keep e power x term here in the left hand side. So keep e power of x here, 1 by replacing d by d plus 1. So here d plus 1 the whole square minus 4 into d is replaced by d plus 1. So d plus 1 plus 3. So remaining cos 2x. So now I am going to simplify. So e power of x into 1 by, apply a plus b the whole square. So a square plus b square plus 2ab and multiply minus 4 inside. So minus 4d and minus 4 plus 3 into cos 2x. So okay, after this e power of x into 1 by, so this is t square and plus 2d minus 4d is minus 2d and this is minus 4, 3 plus 1 plus 4 cancel, so only cos 2x. So remaining this is the type 3 cos 2x. So remaining this is type 3. In type 3 we have to replace d square by minus a square. So this is type 3 cos and sin type. So in cos and sin type, d square is replaced by minus a square, but a is here 2, therefore minus a square, 2 square is 4. So in this type we have to replace only for d square. D square is replaced by minus a square, but a is 2, so minus 2 square is 4. So in this type d square is minus 4. I am going to replace. Okay, so here d square I am going to replace minus 4, so that e power of x 1 by d square is minus 4 and minus 2d into cos 2x. Actually in this is type 3. In type 3 sin or cos type 3 model, d square is replaced by minus a square, but a is 2, so minus 4, but you do not replace for d. So you have to replace only for d square, not for d. So d square minus 4 means minus 4 minus 2d. So this is minus 4 minus 2d. So you can take minus 2 outside, or simply 2 also can take outside. So when you take minus outside, minus e power of x, this term becomes 2d plus 4 into cos 2x. But you see, in this third type, we have to replace only for d square, not for d. But unfortunately we have d. So that I am going to take conjugate to converting the denominator to d square. So now minus e power of x 1 by 2d plus 4 into 2d minus 4 by 2d minus 4, taking conjugate to convert the denominator in d square form, cos 2x. Okay, now minus e power of x, multiply these two, so 2d minus 4 divided by a plus b into a minus b, a square minus b square into cos 2x. Now you see we have d square in the denominator. Again I am going to replace same method. D square is replaced by minus a square. So minus d square 4 to minus 4. So replacing here. So that minus e power of x into 2d minus 4 by replacing d square by minus 4. So 4 into minus 4 minus 16 into cos 2x. Okay, so now minus e power of x divided by, this is minus 16 minus 16 minus 16 minus 32 into multiply cos 2x inside. So 2d cos 2x minus 4 cos 2x. Okay, now cancel minus, so that e power of x by 32 into d. D means differential. Differential of cos 2x is minus 2 sin 2x. So minus 2 sin 2x into 2 differential into 2x differential is 2. But here there is no d, so that you don't want to differentiate. So minus 4 cos 2x. So now you see 2 into 2 4, minus 4 can take outside. When you take minus 4 outside, minus 4 e power of x into by 32 into sin 2x plus cos 2x. So simplify e power of x. So 8 4 7 into sin 2x plus cos 2x. So this is the particular integral. So already we know the solution of the differential equation is complementary function plus particular integral. So solution is y equal to CF plus PI. So finally y is equal to CF. Already we found CF value a into e power of x. So a into e power of x plus b into e power 3x, and the particular integral minus e power of x by 8 into sin 2x plus cos 2x. So this is the solution of the given differential equation. This is the solution.